Intro hook. Imagine this. Every time you type a message, shuffle cards, or search on Google, you're relying on randomness. But it's not chaos, it's math. Let's dive into the fascinating world of probability, randomness, and how it secretly powers our modern lives. Zerg, the law of large numbers. The law of large numbers tells us something simple, yet powerful. The more times you repeat a random event, the closer the results get to the expected outcome. Flip a coin a few times, you might get streaks. Flip it 1,000,000 times and you'll see about half heads and half tails. This law is the foundation of probability, and it's where our journey begins. The 7. What is a Markov chain? Enter the Markov chain. Think of it as a process where the future depends only on the present, not the past. If you're on square 3 in a board game, your next move only depends on your dice roll, not how you got there. This memoryless property makes Markov chains incredibly powerful for modeling everything from weather patterns to stock markets. 943 Ulam and Solitaire. Stanislav Ulam, a brilliant mathematician, came up with the Monte Carlo method while recovering from an illness and playing solitaire. He wanted to know the odds of winning a certain game, but solving it by hand was nearly impossible. Instead, he simulated thousands of games, letting randomness reveal the answer. 1221 Nuclear fission. This idea wasn't just for card games. Ulam, alongside John von Neumann, applied random sampling techniques to model nuclear fission during the Manhattan Project. These simulations were too complex for exact equations, but randomness gave surprisingly accurate results. 1546, the Monte Carlo method. And that's how the Monte Carlo method was born, using random numbers to solve problems that are too complex for direct calculation. It's used in physics, finance, AI, and even video games. 1832, the first search engines. Fast forward to the early days of the internet. Search engines needed a way to rank websites. Simple keyword matching wasn't enough. That's when probability-based algorithms came into play. 1907, Google is born. Google's breakthrough was PageRank, an algorithm deeply tied to Markov chains. Think of the internet as a giant web and a random surfer clicking links. Over time, the probability of where that surfer ends up tells you which pages are most important. That's how Google beat its competitors. 2516. How does predictive text work? Markov chains also power predictive text. When you type, your phone guesses the next word by looking at what usually follows. The algorithm doesn't know your whole conversation history, it just uses the current state. Memoryless yet eerily effective. 3710. Are Markov chains memoryless? And yes, Markov chains really are memoryless. Each step depends only on where you are now, not how you got there. That makes them simple but surprisingly versatile. 2941. How to perfectly shuffle a deck of cards. Finally, let's circle back to randomness in its purest form. Shuffling a deck of cards. A perfect shuffle requires about 7 good riffle shuffles to reach near true randomness. Too few and patterns remain. Too many and, well, you've overdone it. Even randomness has structure. Outro. So the next time you type a text, shuffle cards, or use Google, remember, behind it all is a world of randomness, probability, and a chain of brilliant ideas. If you enjoyed this journey, hit like, share with a friend, and subscribe for more deep dives into the hidden math of everyday life.